I'm going to start recording this, okay? That way you can come back and take a look at it later if you need to, all right? So I just turned on the recording for you. All right, so if we want to learn how to make a scatter plot and we forget how to do it, the command is plot. And one of the cool things about R is that if you come over here down into the console and I put a question mark and I put in plot, and then I hit an enter, over here in the window to the right, it's going to give me a lot of information about how the plot works. Okay, it tells you a description of it, how it works, and then a whole bunch of information about all the different parameters that you can use in plot. Okay, but the basic part, the most basic will be the first thing you see, and then after that, the dot 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 means there's a ton of other things you can put in here, but the minimum you got to put in is you got to give it an X and you got to give it a Y. So, because what a plot does is it plots a scatter plot of an XY variable. So just to make it so that we have something to look at real quick, so I can just give you an example. Just ignore this part, you don't really need this, but I'm going to make some numbers real quick. So plot X comma Y. So what I did is I just put 100 numbers in X and I put 100 numbers in Y and I say plot XY. And when I do that, look over here, see it made a plot or a scatter plot of all those ordered pairs that I just generated. Catherine, how are you?
Hi.
Gary and I are just going over last week's lab, so we'll get some fresh questions here in just a bit, okay?
Cool.
All right, so what you need to do here is you need to come in and use that command. You got to say plot, and what they want us to do is they want us to plot the weight variable versus the BMI. So the thing that is important is to realize that you're working here, when you work in R, you're basically working with spreadsheets. They're called data frames, but they're spreadsheets. So if I click on this CDC data frame right here, you'll see there is all of the data for weights and for heights. They're all in here, okay? So in order for me to be able to get R to plot a variable out of this data frame, I got to give it two pieces of information. The first thing I got to do is give it the name of the data frame, which is CDC. And then the second piece of information I got to give it is the column name that I want. What is the variable out of there that I want? So the variable that I'm going to want is going to be weight. So that's my X variable. And then my Y variable is the BMI. And the BMI, we made that up here, back up in this line right here, okay? In other words, that creates the list BMIs. In fact, if I come over here to values, I should see BMI now. There's the values that I just made. So Gary, you still with me? Is this making any sense? Give me a yes, no, Gary, thumbs up, thumbs down. Okay, get more sense. All right, cool. All right, so now I'm going to come down here and I'm going to say, okay, that's all I need to do. And if I click on this little green button over at the end of my R chunk, it'll run it for me. And it'll give me a sample or a preview it down below in the RMD. So give that a go and let me know if you have any success with that, okay? So try that and then give me back in the chat whether you were able to get the same thing that I got or not, all right? You do need to make sure you come up into the previous chunk up here and click that green arrow first before you click the green arrow down there, okay? Catherine, what can I do for you?
Hi.
How you been?
Slightly confused about this, about what we needed to do in, what you wanted us to calculate in our studio this week.
Okay.
Um,
On on your own problems?
yeah, I need to, let's see, I need to get to There we go. So let's see if I go. I can't remember how to share my screen.
I'm sharing right now, so it's not going to let you.
Oh, yeah. Okay. That's cool. So
Hang on, I
it
can stop sharing for a moment and let you share, and then I'll take
cool.
it back. Okay. All right.
So I have it pulled up. I have the problem pulled up now. Now it's time to get creative. Find the mean and the standard deviation of the female weight variable.
Yes. So as soon as you see somebody say it's time to get creative, you know they're making it hard, right? I mean, that's
Well, and hey, I love creativity.
There you go. There you go. Giving you the option to be creative, right?
It's just when I tried entering the command that you said,
well, show me what you typed. Let me see what you got, because you should be able to share now.
Let's see. Oh, I think it deleted what I typed earlier. That's rather unfortunate. So I tried typing SD, and I'm gonna copy and paste that.
Here, let me share mine again, so we'll have one to look at. Okay.
Okay.
So you're talking about down here, right?
1 second. Yes, that problem.
Right. Okay. So this is one standard deviation either side of the mean, okay? So the way...
Okay. And I forgot one of the questions that I wanted to ask you. So one standard deviation away from the mean, does that mean, is that the same thing as the standard deviation? You know, like you read all of these statistics, you read the standard deviation in all of these academic papers, and you read the mean is this with a standard deviation of da 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 da.
Yeah.
Is that one standard deviation away from the mean?
Possibly. There's a lot more coming. We're going to talk about that. It's this thing. There's usually this thing called a confidence interval that's built based upon the mean and the standard deviation.
Okay.
But we're kind of a ways away from it. But we're building the tools now. But you're on the right track. So I can give you like a 30-second tour here of what you're.
Let's come back to that.
Okay. Well, this is actually going to help, I think.
Okay.
Okay. So if I had a distribution of values, right, and they just happen to look something like that, and that's the mean right there, and this distance right here was a standard deviation,
okay,
then that's going to be the mean plus one standard deviation, and then this point over here is going to be the mean minus one standard deviation. And what we want to know, what we're looking for, what this problem is trying to find out, is what % of the data fall inside of that interval from there to there.
Okay.
Hang on just a second. I'm going to get rid of that phone. I'll be right back. So anyway, so that's what we're doing, okay? Okay, so let's go back to R, all right? So in the first one, is Catherine, you still with me?
Yeah, I'm still here.
Okay, or you locked up there for a moment, okay. So in the first one, that's what this did. So it calculated the subset, what's in here.
You're kind of going in and out, and I'm kind of wondering.
Yeah, you know what? Hang on just a second, because it just gave me the thing that my internet's acting up. So let's give it just a second and see if it comes back.
Okay.
Okay, so let me check in with Gary real quick over in the chat.
Cool.
Did the plot work, Gary? Question mark. Gary, were you able to get that plot to work? In other words, were you able to get it to look like this down here? I'll leave the chat up there, Gary. When you get to it, tell me what you got, okay? Not yet. Okay, so main thing, look, I'm going to put this in the chat box for you. This is the command that you want. That's the command you want in that R chunk, okay? It's got to be below the R. It's got to look just like mine, okay? Okay, all right. So I'm gonna go back for just a moment over here with Catherine. So Catherine, here, when you do the next one, here's what you want to do. I'll show you. It's super simple. Copy these 2 lines of code, all right? Hit a return and then paste them back in here. And you're going to change it from 1 sigma to 2 sigma. So for 2 standard deviations, right?
Okay, because I tried typing 1 sigma, 2 sigma, and I must have been entering something wrong because I kept getting error messages.
Okay, well, hang on. I'm not done. I have to modify this code a little bit also, okay? So let me go back to the whiteboard here for just a moment. So if I was now talking about 2 sigma, right? If I want 2 standard deviations here, say the same distribution, that's going to be over here. That's going to be mu minus 2 sigma and up to here at mu plus 2 sigma, right? So I'm covering a lot more of this time because this distance right here is 2 sigma now, right?
You're getting really cut off. I can't see everything that you're writing.
Really?
Yeah.
Huh. That is strange. Okay, but this looks okay?
Yeah, I can see our studio.
It just doesn't like this.
Yeah.
Well, dang. Okay, well, let's... There's more than one way to skin a cat. Hang on a sec.
I don't know. Maybe if I went out of full screen or something for the paint, maybe that would help.
Well, Zoom has a whiteboard. I'll use Zoom's whiteboard for a moment, okay?
Okay.
All right, so can you see this okay?
Yes.
All right, good. All right, we'll just use Zoom's whiteboard instead, all right? So that's mu. That would be mu plus a sigma, okay? My thing is Zoom's whiteboard does not like my pad for some reason, so we'll have to go a little slower. If I go too fast, it freaks out. Okay, and that's mu minus 1 sigma. So in other words, this distance here, actually, it's right there. Ignore that. That's not it, okay? So this distance from here to here, that is a distance of a sigma.
Okay.
And the area inside of here, one way representing that is that's the percent of data that, stop it. It won't let go sometimes. That's the percent of data that fall between plus or minus 1 sigma, okay? So now when I go to do the next interval, this thing just wants to drive me crazy. It's going out to now to mu minus 2 sigma, and up here to mu plus 2 sigma. I will write slow so you can keep up with me. There you go. All right, so now this distance right here is now 2 sigma. All right, so let's go back and see how what that has anything to do with what we were just doing, okay? So back here, look, it's x bar minus 2 sigma. I got to have 2 standard deviations. You with me?
Let's see. I see 2 sigma outside of the parentheses, but how do you say that inside the
Yeah, don't worry about this. This is just a title. This is just a variable name, okay?
Okay.
All right. And what I'm dumping in there is a subset from the female heights where the female heights are greater than x bar minus, and then I got to put in a 2 times. And it's really important you put the multiplications. If you put a 2 there, it's going to blow up because R is very persnickety. It doesn't let you get away with that. You got to say what you meant, and you meant multiplication, so you got to put a star in there or an asterisk, okay?
Okay. Yeah, I didn't see that.
And then I got to put another 2 star STD, okay? All right, and so now if I run this, that's the percentage within 1 standard deviation. That's the percentage within 2 standard deviations.
Can you scroll down? I can't see. Oh, good. Yes. Excellent.
Is it making more sense?
A little bit. I think I understand the concept of standard deviation. It's R that I'm struggling to understand. R and R Studio.
Okay. Well, it's hopefully going to get easier. The subset command, we're introducing it now. This is kind of pushing you as hard as I'm going to push you for learning R code. Okay. We're going to use it after this like a big overgrown calculator.
Okay.
You know, like if I want the mean of a data set, I'll go mean and then the name of the data set. That's very similar that, like, if I say in last semester in 102, did you guys use the TIs to calculate some data stuff?
Yes, we used graphing calculators.
Okay, so did you do 1 var stat by chance?
1 var stat. Let's see.
Did you calculate like means of standard deviations of data sets?
Yes.
Okay.
We didn't actually have, we didn't like have some sort of function or something to punch in, but we calculated it the long way.
Oh, okay. Yuck.
and then once we figured out how to do it,
right,
he did show us how to do like the 5-number summary and that sort of thing.
Okay, yeah, right. So what you did, I'll just so you know, I'll show you the equivalence. So it'll give you kind of an analogy so it'll make sense to you, okay? Gary, I'm checking back in with you real quick here. I want to see if you got that graph plotted, okay?
Yeah, this was what she used.
Yeah, okay. So, wrong one. Yeah, is that the one I want? Yeah, I think that's the one I want. Okay, here we go. Let's make it a little bit bigger here so you can see it. Okay, so if I go into stat and I go over here to calc, you see the first entry, 1 var stat?
Yeah.
Okay, and if I say go in here and I calculate, it gives me all these crazy numbers, right?
Yeah.
Okay, well, back over here in R, same idea, okay? If I want to make the console come up so you can see it here, okay?
Maybe scroll down a little bit.
I'm going to make the window smaller for you.
Okay.
Okay, yeah, it might be better if you, I don't know, maybe the full screen's not working for you, but that's okay. We're going to make this work, okay?
Cool.
So if I go summary, female heights, that's like doing a 1 var stat.
Yes.
Okay, same idea. Okay, so we have to, I would be remiss in my duties in not showing you some of the power of what this thing can do, what R can do. But the bulk of what we're going to do is going to be like that. We're going to use it like a calculator. We're going to take the built-in functions, just like you were working with this thing, and make them do it for you. Okay?
Yeah, I figured out the summary fairly well.
Yeah. Well, if I want to find just the mean, you see, the thing about R, their philosophy was give them just what they need. Okay, they don't do the shotgun approach. They don't go here, let me give you everything. Okay, they don't right? So they give it to you piece of just what you. It's all a la carte. You want just that thing, I'm going to give you just that thing. If you want more than that, we'll give it to you, but you got to ask for it. Okay, we're not going to give it to you just because, right? So it's very atomic in that sense. So if I want the mean and the standard deviation, I type in the mean, I type in the SD. If I want the interquartile range, I type in IQR. And it gives you all those things, okay?
Yes.
If you want the 5-number summary, you type in summary, and it gives you the 5-number summary.
Yeah, that makes sense.
Okay? All right, I'm going to check back in with Gary. Gary, where are we at with that graph, buddy? You got it? It's working? It's on there? Life is good? Yes, it is. Okay, good. We got the plot. All right, we're feeling good. We got that part done. Okay. All right, now they want you to come down here. They're kind of up in the ante a little bit, and they said, we want you to build some side-by-side comparative box plots, determine if the men tend to view their weight differently than the women. You'll need to insert an R chunk here. Okay, so you come up here where it says insert, click on that, and grab an R chunk. And what that will do for me, oh, sorry about that. Hang on, I put my cursor where I wanted it first. Click down here, so you're on like a line 28 or whatever. So down where you want to actually put the chunk, okay? Okay, put in, and then go ahead and say insert R, and it'll give you a chunk. Okay, and now we want to do a box plot. So I'm going to type in the word box plot.
Oh.
And we're going to go CDC. And the variable we want to do the box plot on is desired weight, because if we're talking about how they're viewing their weight, we're talking about their desired weight, not their measured weight. So you're going to go CDC $, and then weight desired. And then from there, if you look above your tab key, all the way over on the left-hand side of your keyboard, just to the left of the 1, you'll see that the second function is this little guy. It's called a tilde. And then I'm going to put in CDC $gender. So what that basically said, what I just told R to do is I want you to make a box plot of the desired weights, and I want you to do it based upon gender. So if I run that, what that's going to do is give me 2 box plots, one for the men, one for the women, with their desired weights in the box plots. And a box plot is just a fancy way of graphing a 5-number summary, where this width of the bar, the width of the box, that's the interquartile range. The minimum and the maximum, those are the numbers up there. So one of the things that we see about this data set, which I actually called these guys on it and sent them a message, but apparently they haven't fixed it, is I don't really think somebody wants to weigh 6, unless we're looking at sumo wrestlers here. We got a 500-pound desired weight and almost a 700-pound desired weight. So something I don't think was quite right on that data set. Not an equals, Gary. You're on the wrong side. Your left-hand side, not your right-hand side of the keyboard, bud. Over there by the number 1. And you want the second function, it's a tilde. And you need to put a $sign between CDC and gender. Okay, hang on. I'm going to come back over to Catherine here for a minute. Okay, so Catherine, we got 2 of them. We got to go for the 3rd because they want 3 standard deviations, right?
Okay, 1 second. I've been fiddling, trying to see if I can figure it out on my own.
Okay, cool. Then I will not bother you. You let me know when you want me to come back. Okay.
Oh! I found it. I found what I was trying to figure out earlier. Hey! At least I think I did. Maybe.
Okay. That's good.
It's exciting!
Yeah, it is. Yeah. All right, so Gary, did you get those both to work now?
Okay, so I found the thing at the bottom where I finally found the command that I was looking for earlier.
Okay.
The 1 sigma equals subset. And I did get something back, the example, but then I'm having a hard time figuring out what I need to change to get the other standard deviations.
Okay, I'm gonna stop sharing. You show me, okay? Show me what you got.
What it is. Can you see it?
Yep, see it just fine, perfect. I'm just gonna be looking this way now because you're over there.
So I tried substituting the word 2 in for 1.
Right.
Right there.
Well, that's all you did there is you changed the name of the variable, but you didn't change any of the code. So let's where you're at, where you're pointing. Let's walk through the code and let's read it in English. Okay, so go back over.
Wait. So maybe if I were to go up and I put 2 star, is that what you're saying?
Yeah, but wait, let's make sure it makes sense though, Catherine, okay? Why you're putting the 2 star there, okay? All right, so go over to the equal sign. Just go over there and we're going to walk you through. I'm going to read it in English for you, okay?
Okay.
All right, so what you did is you took the variable 2 sigma and you set it equal to, now when you hit the word subset in R is an open set brace. It just opens up a set brace, okay? So I'm going to make something for you. I'm going to make you a set of numbers, all right?
Right.
So now go over to the next thing. Now you see FH, that's the next thing after there, okay?
And that's female height, right?
Exactly.
Oh, wait. So I want to type in weight, don't I?
No.
What?
No. This was all about heights. There's no weights.
Okay.
Hang on just a second. I want to see something. Go back up for me if you wouldn't mind. Go back up to your lab and scroll down a bit so I can see it.
Oh, here.
No, I got it. Okay. All right. Here's the problem.
What?
You got to do a little cut and paste for me.
Uh-oh.
Well, it turns out you and Gary, or not Gary, you and Damon are just too quickly out the gate. You got, well, what happened is apparently when I updated this thing and I put the updated version up there, right? It didn't stick. And so you and Damon, because you guys are so on top of it and you guys got it, you got the old, this is last year's version of it. I've updated it significantly to make it easier to understand. And so you have just the on your own part, okay? Everything else is the same. That's the only thing I fixed was on the own, okay? So you got to go get the new version of it and cut and paste that on your own in there, and this is going to make a hell of a lot more sense, okay?
Okay.
All right? Because I take you through step by step and build it. And that's why you're going, oh, wait, I need the weights. That's why it doesn't make any sense, because last year I used weights. This year I'm using the heights.
Wait, okay.
All right? So you see how this looks different on the on your own on the, doesn't this look different on the, scroll back down again. Look at the on your own on the HTML version.
Wait. Just the height variable. Down there.
You see how it looks different? See, all this should be in the on your own. So go back over to RStudio for just a sec. All right, go and open up your
my markdown?
Yeah, open up your markdown. So look, you see how on your own, how short it is? There's hardly anything there, isn't it?
Yeah.
Okay, the on your own should be that whole chunk you're seeing in the HTML. So what you can do.
Wait. Let me get this straight. This.
Keep going. So you see exercise.
Yes. This whole thing should be in.
Yes.
Markdown. Oh.
Yes. There was. I kills me because I spent a ton of time updating this thing, making it a heck of a lot easier to fix. And somehow when I know I uploaded it. So somehow when I uploaded it, it didn't go. It didn't stick when I put it up into Canvas, and it kept the old version up there. And so you and Damien got the old version. I'm pretty sure I sent out an email saying, hey, by the way, get the new version. Don't get the old one. So I would just go ahead and go back. Just go back into.
I want to check my inbox and see. Did you send it to the Canvas inbox?
Yeah, I'm pretty sure that night after I got done with Damien. I'm hoping I did. I was pretty sure I did it that night.
I think I remember
Damien had it going Sunday night. He's asking me about it Sunday night.
Sunday night. Let's see.
Well, maybe I didn't do it.
Friday.
No, it would have been Sunday because Damien asked me about it Sunday. Sunday or Monday. Actually, it might have been Monday because Monday was when I did that extra office hour. Try that one. No. I didn't do it. I thought I did. Keep going. No, that was about the discussion question.
Huh.
No, all right. I guess I didn't do it. Well, I did update it. So go back. Do me a favor. Go back into the class for a moment.
Let's see. Wait. Maybe to the homework?
Yeah, go down to the assignment for me.
And do you want me to download it?
Yeah, just grab it one more time because we're just going to cut and paste just that part out into the new.
I keep forgetting. It doesn't. Okay.
Okay, so what we're going to do is this, where it says Lab 2 up there. So you're going to start on line 10.
Ah, there it is.
Okay, grab that and highlight all the way down to textbook exercises, but we don't want to copy the word textbook exercises.
Yeah.
That's why what I was doing wasn't making any sense to you, because you keep going, you got some more to go. Keep on, there you go, stop right at line 61, or 59, I'm sorry, yeah, perfect. Okay, go ahead and copy that.
And take all this out.
Yep, and paste.
Cool.
All right, so now hopefully, go ahead and knit that real quick so we can take a look at it.
Okay. Let's see. Ooh.
Did it do it?
Oh wait, that's assignment 2. Never mind. I thought it did.
I think it's doing it. I think you just got to be patient with it. No? No, you just opened up the HTML code.
That was the assignment too.
Yeah, when you knit it, it should open it up in your browser automatically. There we go. Just had to think about it for a bit.
Yeah. Okay, cool.
Okay, cool. All right, so let's go back into our studio. Just go ahead and you can just X out of that. Okay, scroll back up for me. Okay, we got the word lab 2 in there twice. Scroll down just a smidge. Just a smidge, come down slow. Yeah, okay, yeah, get rid of line 10 through 13 for me. It's probably why it was so slow, because it was doing that twice.
Okay.
Okay, great. Okay, go ahead and scroll down a little bit for me now.
Maybe.
Or do that, that works too. Okay, so see the first thing right there on your own is creating a subset of the female gender, right? So that's in fem. And then the next one down is, again, this is from, you could have done on the console if you watched the video. Next one down is the female height.
Right.
That's on line 25, right? And then down a little bit lower, keep going down a little more. So, okay, now we want to do, this is where you get to do some stuff. So what is the summary statistics for the female height? So that would be just summary FH.
Okay.
So on line 32, you would put in summary FH. And that's going to give you the, when you knit it, it's going to go ahead and give you just the summary statistics. But you want the summary of FH, Catherine. You want to give it, so you want the, the mean, the median, and all those things.
What?
That's okay. Just go ahead and hit return. It'll make a new space for you.
What did I do?
Go ahead and hit a backspace for me. Okay, hit a return. Okay. Now type the word summary.
Right.
And you can do autocomplete. Hit a tab right there. You go. Perfect. And now put FH in there.
FH. There you
Okay.
go.
All right, cool. So what that's going to do, that's going to give you the summary statistics for the FH vector. Okay. So in other words, it's going to tell you the mean and the median. And so remember in the last lab that we did, last discussion question, is we wanted to know about the relationship between the mean and the median when we're talking about whether or not we need to use a robust statistic or not, right?
Okay.
So the thing we came up with from that was, if the mean and the median were like this, in other words, they're very close to each other, no need to use a robust statistic. On the other hand, if the mean was very different from the median, then you want to start thinking about using the median. Because what that indicated for us is that the mean was probably getting dragged towards some extreme values, okay?
Right.
So that's what that question is asking you to think about, all right?
Okay.
All right, so the next one is they want you to take the mean and the standard deviation and save those in X bar and STD. That's where you get, all right? So scroll down a little bit further. So that's just mechanics in B. All right, and now we go down to part 2. They want to know, what is the shape of the distribution? So to do the shape of the distribution, that would be a histogram.
Okay.
All right.
So I'm going to put histogram.
Or you can just do hist.
Oh.
Save yourself a little typing. Just do a hist.
Maybe I can do this autocomplete.
You can even hit a tab now. There you go. And you want to do for the female's height, so it's hist of FH.
Okay.
Okay. All right, so go ahead and knit that. Let's see what we got so far, okay? Just give it a sec. It's having to think about it a little bit. CDC is a big data set. It's got 20,000 data points in it.
Yeah, I remember.
Yeah, so that's what the little red stop sign up there saying is it's taken a bit for it to think about it. Hey, there you go.
Cool.
Okay. So go ahead and scroll back down. Let's take a look at that histogram for a minute. Oop, whoa, a little fast. Come on, back up. Okay, so what would you describe the shape of that histogram? What's it look like? Bless you.
Excuse me. Well, it looks pretty symmetrical, but I do see some outliers.
Yeah, well, it's.
If I look carefully.
The thing is, yes, you do have some unusual events in there, but the vast majority looks bell-shaped, kind of symmetric, all right?
Okay.
You got to remember, real data is going to be messy. It's not going to fit exactly to a nice, beautiful bell-shaped curve, okay?
Right.
And so that is pretty darn, like you were saying, symmetric. That's really actually, after you've looked at a number of these, you go, wow, that is amazing, how symmetrically and beautiful that is, okay? And so scroll back up just a smidge for me. Okay, stop there and take a look at the summary that we did. Look at the mean and the median.
By summary, you mean this one?
Yeah, and look at the output just right below it.
So mean 64.37, median 64.
Yeah, they're almost the same, aren't they, right?
Almost.
Yeah, and so that's a really good argument in favor of symmetry also.
Okay.
And so what that means is that we would use the mean and the standard deviation as summary statistics for this distribution. In other words, we don't need a robust statistic here. We only use robust statistics when we need them, and we don't need them here. So in this case, we're better off using the mean and the standard deviation to describe the center and the variability of the distribution, okay?
Because now, connecting back to last week, you say the mean and standard deviation are preferable because they include more points?
They use everybody.
Yes.
Yeah, where the median and the interquartile range, well, the interquartile range uses 2 numbers, and the median uses 1 number, right?
Right.
So you'll see in the big picture, we really want the mean and the standard deviation wherever we can, because they tend to be better descriptors of the distribution for us when it's symmetric, right? When it's symmetric, right, then the median and the interquartile range. Okay, so now scroll down. So here's what the last piece, the part we started work on when we opened up here, is we're looking at that drawing right there, right? And we want to know what percentage of the heights fall within plus or minus 1 standard deviation, what percentage of the heights fall within plus or minus 2 standard deviations, and what percentage of the height fall within plus or minus 3 standard deviations. And so to do that, that's where we're going to actually use the subset command. So if we scroll back over, go back over to RStudio now, we can go ahead and close this knit file. So if we scroll down over there, or you go ahead and do what you did before and maximize that window. That's probably the best bet. I liked what you did there earlier. Yeah.
What, this thing?
Yeah, that's the best way of doing it. Okay, so scroll down just a smidge. And now this is where...
This is what I was thinking of.
Yeah, this is the part, okay? So what you do is you're going to take line 56 and 57. You're just going to copy those 2 lines.
Okay.
And then once you got those copied, click right after the 100. So click right next to the 100 there. And then hit a return, because we want to stay inside of the chunk. And then go ahead and paste in those 2 lines you just copied.
Oh, and then I'm just going to change this.
Yes, you're all over it.
And then,
yeah, we're going to have to do a little bit of, yes, that's the first part, to change the names. But we got to change it in both places. So you see in line 59?
9, yeah.
Yeah, it's got to say two sigma inside of the parentheses. It can't say
Oh, yeah, that was what I was having problems with.
Because see, what you did in line 58 is you assigned that subset into 2 sigma, and the same thing in line 60, you assigned that subset into 3 sigma. Okay, now you got to actually go make it 2 sigma. So go back up to line 58. You see where it says SD in line 58? That's got to be 2 sigma.
And so that's where I'm going to put 2 star.
Yep.
And then 3 star.
Yep, but you can't do it just there. Now you did the lower end, but you didn't do the upper end, right?
This end?
Yep.
Okay.
Okay, go ahead and knit that thing. Let's see what it does.
Should I?
You can just run that chunk. That's fine. Just run the chunk. Let's see what it does.
Okay.
All right, so those numbers, those are percentages. So the percent of data that falls within plus or minus 1 standard deviation is about 74%, 96%, and about 99.4%.
Okay.
So a theory that we're going to learn in the next chapter coming up here next week is that if it's a bell-shaped distribution, then about 68% of the values are going to fall within plus or minus 1 standard deviation, 95% within 2 standard deviations, and 99.7% within 3 standard deviations. And so those numbers are looking pretty good. They're pretty close to what we expect theoretically. Those are empirical. The theory would say a little bit different, but it's very close.
Okay.
Okay? Okay, how you doing with the textbook stuff?
Let's see. I think I mostly got it.
Okay.
Let's see. I don't know that I necessarily have questions on any.
Okay.
But at least anymore, because
Okay.
I worked them through as best I could.
Okay. Don't ever feel shy about posting on the Q&A form. If there's one you feel like, I'm not 100% on this, you can put the question, you can put up your answer, stick it on the wall and see if anybody agrees with you.
Well, and I think part of it too is that I'm finding that sometimes I just kind of have to play with it. I have to knead it out like you would knead bread or something, Like, what was it? This one here, I had such, I'm still screen sharing.
Yeah.
I had such difficulty figuring this out until I randomly decided to substitute numbers into the numerator and denominator. And I knew that a top-heavy fraction would give me a number greater than 1.
Mm-hmm.
So, so I think I have figured that one out. Feel free to.
I'm looking at it right now.
Tell me what you think.
Okay, so you totally have the right idea. Your idea is perfect. Okay, but I think you got the proportions a little backwards. Okay, so on part B, looking at line 111.
Okay.
So the proportion greater than 1 would have the median as lower than the sample mean, which is correct, but that's not what's going on in this one. In B, it's the proportion is less than 1. It's not greater than 1. So look at the less sign. It's less than 1 here. I understand that the that line above is kind of gibberish until you knit it. That all I did is I put in the code up there to make it so when you knit it, it looks just like in the textbook. Okay.
Okay, so maybe my problem is partly understanding the concepts of skew and figuring out, oh, right skew means it's going this direction, left skew means it's going this direction. So maybe I'll need to go back.
No. I think let me read it again. I may have misread what you read. Let me read it one more time, okay?
Okay.
Portion this okay, so the problem, yeah, okay, so it's you've got it half right, okay?
Okay.
All right, so if X bar give me just a sec, Catherine. I got to read it a couple of times, get it straight in my head what you're saying, okay?
Okay.
Okay, so you say the proportion greater than 1 would have the median as lower than the sample mean, which is true. That part is true if the proportion is greater than 1, right?
Okay.
That's true, okay? But that's not what is in B. If you look in the textbook at B, the proportion is less than 1.
Oh.
You follow me? Okay, so
Yeah.
if the proportion is greater than 1, the median would be lower than the sample mean. That's true, yes, that because you're right about the ratio. It means the numerator's got to be bigger than the denominator, right? Okay, don't raise anything yet. Let me finish it. Finish reading, all right? All right. So I got that part figured out. Let me get this second. So given the distribution a positive skew. That is correct also, given the distribution of positive skew, because what you're saying there is usually the way I get it in my head is the mean is bigger than the median if the proportion is bigger than 1, right? The numerator is bigger than the denominator if the proportion is bigger than 1, right? And the mean's in the numerator, so if that number is bigger than this number, then we know we're bigger than 1. So it would be a positive skew because that meant that the mean got dragged towards the positive side. So everything you wrote is correct, it's just in the wrong place. You follow me?
I think so.
Okay, so same thing's going on with C. Just swap B and C and you're good, you're golden, okay? All right? You just got them in the wrong spots.
That makes me nervous about turning this in because I don't know what other mistakes I might have made.
Well, I'll tell you what I'm going to do. I unfortunately, I mean, there's too many of you, not enough of me. And so what I have to do is I type up the key and I paste that, like the last assignment that I just finished grading. And so what I'm going to do is I'm going to give you the solutions, and then you've got to do the HTML file. So you just open it up and look at your markdown, your HTML file, and compare the two. I usually look at maybe 1 or 2 problems closely at the most. That's all I got time to do to get through all the stuff I got to get graded.
Okay.
And so then you go back and take a look at the ones, the keying, you can compare them if you're worried about anything. But I would not have taken points from you. You follow me? Because you totally got the concept right. You just put the answers in the wrong place. That's not. That's just one of these, that's not a conceptual problem. I mean, you totally got the idea dialed, so. All right, I got to finish talking to Gary, and then we're out of here. We're 13 minutes over, so.
Okay, cool. Thanks a bunch.
You are welcome, Catherine. This is also going to be, I recorded it, so if you want to go back and look at any of it, it'll be up soon after we get done, okay?
Cool.
All righty, you have a great weekend.
Yeah, you too.
And I'm going to check in with Gary one more time. Gary, did it work? Okay, Gary, if you can't get it to work as HTML, give me the RMD. That's all I need, okay? Catherine, go ahead and stop sharing for me so I can show Gary something, okay?
Oh, yeah, okay.
So Gary, what you can share with me, hang on a second here. Is if you come in, let me find the right assignment so I can show you what it looks like there, okay? So say assignment 2, okay? Yeah, you see the RMD file? You can submit that one, the .rmd. The one that's highlighted, yes, that one right there, that works. And we don't want to open it because we're going to try. You want to do the, yeah, there you go. Now you're cooking with gas. And so, okay, and then click on submit assignment and bada bing, bada boom, you've got it turned in, okay? And you're going to do the same thing for me in assignment 3. I just want you to submit the RMDs for me, okay? All right, so you need to go and get back into modules. You got to go find assignment 3, and you need to get working on that one, okay? Click on modules, Gary. Scroll down to week 4. Keep going, that's 2. I'm gonna go down to module 4. There you go, okay, go down, all right, slow down. We don't wanna go there. Go down to assignment 3, 4.3, go to 4.3 for me. Okay, there you go. So you'll find the lab and the exercises there. I'm looking to get that from you by Sunday, so you need to get working on that, okay? All right, okay, so Gary, you know what your marching orders are, right? You need to get going on that one. Go get going on the textbook stuff. I'll help you with the lab, but Catherine and I just did most of the lab. You can watch this video again. This will be posted right after I get done. You go back into Zoom Confer, you'll see one of the buttons is recorded sessions, and you can click on that and you can watch what we did tonight, okay?
By the way, Professor.
Yeah, student.
I just discovered that I can move around on your screen. So if you want to, if you prefer using Paint, then I'm perfectly fine with that.
Okay, so you figured out how to move the windows around?
Yeah, I think so.
Okay, cool. Okay, well, remember that for next time. So,
yeah,
you know, it's not really a preference. It's just for whatever reason, the Zoom whiteboard and my tablet do not get along. So it's
understood.
Yeah. Yeah, Gary, I'll go take a look at it. I think I opened it back up so that you can look at that. All right. I'll go look again and make sure that it's open for you. All right, you guys, I got to get some sleep. I'm calling it a night.
Yeah.
If you got any more questions, don't be shy about posting them up for me, okay?